Hey Igor, what's up?
Hello gerGo, I go straight to the point. I got H2S from the Bambu Lab for the review, and first they sent me the US version, and later I got the EU as a replacement, and they told me that I can keep the US version for spare parts, but it is pity that so great printer to be used as a donor. So if you are ready to modify it, I can give it to you.
Wow, Igor, I would love to. Thank you so much. I can be there in like 20 minutes.
Sure, see you soon then. Bye.
Bye now, I'm on my way. I never thought we'd have the opportunity to test a Bambu Lab printer on this channel, let alone their latest model. Based on all the hype, I had a few big questions though. How does the famous Bambu experience from unboxing to printing compare to our other printers? How does the lockdown but well-tuned Bambu Studio compare to our favorite Orca slicer? What upgrades will we need to get immediately with the kind support of PCBWay? And the biggest puzzle of all, what is the best way to use a 110 volt 3D printer intended for the US market here in Europe? I found solid answers to all of these, and by the end of this video, you will too. This is gerGo, and you're watching gerGo Print 3D, the YouTube channel where my little nephew Levi and I have the time of our lives discovering the hottest tech from 3D printers to laser machines. And thanks to you, we've just passed 1 million views across all videos we've published. Can you believe it? Just like the others, this one has translation-ready subtitles, chapter markers, and now even multi-language audio tracks too. The first big shout out and thank you goes to Igor from MyTechFun. Of course, I'm sure you could tell from my voice during the call, I could hardly believe his generosity. This isn't our first collaboration either. He invited me to participate in his functional prints project last year, and we met multiple times to work on our reviews of the eye dryer just recently. And another thank you to PCBWay, who are once again sponsoring our channel. This time, they helped us get official accessories for the H2S, which you will see later. PCBWay can enable your projects too, with their expertise in printed circuit boards, laser cut parts, or tricky 3D prints. You don't have to own specialized machinery for rarely needed materials. This month, they have specials on purple PCBs and FDM prints out of TPU. Don't struggle with flexibles. Let PCBWay help you with the TPU parts. The higher the weight, the bigger the discount, up to 80%. Check out their offers at PCBWay.com. Not 20 minutes later, but soon after our call, I arrived at Igor's place. This wasn't even the first 3D printer I picked up from him. Remember that Sovol SE08 Max beta unit that was accidentally sent to his address? We met at his workshop, then we carried the unopened box to my car. It was a pre-release unit, so it even had a secondary box to hide the model name. It took a few attempts for us Tetris experts to get it into the back of my little car, and I think that's where the box got a little damaged. How far did the damage go? I had to wait a few days to find out because Levi was adamant about taking part in the unboxing of such a legendary device. We've unboxed a good few printers by now, but this was most similar to the Acrylic K2 Plus, which was clearly influenced by Bambu Lab designs. I wish Levi was here for the K2 Plus unboxing then, with its 40 kilos. We first lifted this 35 kilo box onto our table, but after removing the outer layer, we realized it's better to start on the floor.
We actually didn't get these from the company of Bambu Lab. We got these from one of our friends.
We probably should have read the instructions on the box because we opened it from the top and got to the pizza box of accessories a bit too early. And its content was a bit underwhelming. With a premium printer like this, you have expectations. But as the old Hungarian saying goes, you measure with stingy hands, for you are a great lord. It feels a bit like Bambu was pinching pennies here. No fancy toolbox, no flush cutter, no tweezers, though they did include blades for a 3D printable scraper, which is actually a pretty cool idea. We get a spare 0.4mm hardened steel nozzle and a filament cutter blade, but that's about it. No filament samples either. Creality was much more generous. After our little detour, we were back on track. We removed the 4 tabs at the bottom and lifted the box clean off the printer. From there, it was a team effort peeling away layers of tape, plastic, and foam. The printer was incredibly well packaged, and my worries about that damaged box completely vanished. In fact, Levi quickly found a good use for the air bubble mattress he found at the next layer as we checked the next recommended steps for the unboxing. Our resident master technician tackled the staggering 14 screws securing the AMS unit inside the printer and the gantry. Everything is so well labeled that a 12-year-old can do it easily, while I handled filming. The AMS unit itself feels much lighter than the material changer systems from either Creality or Anycubic. And then a mystery. So there was a piece of stone in there, very strange.
I'm gonna keep that. This is Chinese rock.
It's Chinese rock, or maybe it's a rock from the moon.
I don't think so.
Tucked away with spare PTFE tubes and desiccants was this, a 3-prong US power cable. This, along with the label next to the power inlet, was the final confirmation. This is indeed a 110 volt machine. Now, at the time of unboxing, we only had this suspect looking 1000 watt voltage converter, which sounds big, but the printer's label states a 1250 watt peak draw. So this wasn't going to be enough for printing. But we couldn't just stop at unboxing. After setting the converter to 115 volts, we took a deep breath and flipped the switch. And it worked.
We need this.
English, please. We ran through the initial self-tests, motion system, Wi-Fi connection, even a 30-minute firmware update that actually took 15 minutes, all flawless. But we had to stop here. Before any heating elements kicked in, it was time to find a real power solution. So how do you safely run a 110 volt, 1250 watt appliance in a 230 volt country? My first thought was, can we just modify the printer? The good news is the main power supply is universal. See, it says 100 to 240 volts. The bad news, the two most power-hungry components, the heated bed and chamber heater, are strictly designed for 110 volts. See, the real danger comes down to a simple law of physics. There's a quadratic relationship between voltage and power. In basic terms, if you double the voltage going into a simple heater, you don't get double the power, you get 4 times the power. Pumping 230 volts into a bed heater designed for 110 would try to draw nearly 5,000 watts, causing an instant meltdown. It would be a very short, very smoky, and very expensive experiment. Now you might think, can't I just swap them out for the EU versions? And while that's a nice idea, it opens up a huge can of worms. Sourcing these specific parts is difficult, and you have to wonder what else is different. Is the wiring a thicker gauge? Are the relays or fuses rated differently? The only sensible option is an external step-down transformer. A big heavy box that safely converts our 230 volts down to the 110 volts the printer needs. But which one? The printer's label says 1250 watts peak. A common rule of thumb is to get a transformer rated for at least 2 or 3 times that. So my first order was this 3000 watt Joseon unit from AliExpress. At the same time, Igor, being the thorough guy he is, asked Bambu Lab support directly. The recommendation? The same thing, a transformer, but they suggested a whopping 3800 watts or more. That seemed like a serious overkill, but it got me thinking about quality. To cover all our bases, I ordered a second, more powerful unit, a 5000 watt transformer from a better known brand, Vivor, but also from AliExpress. When they arrived, the difference was immediately obvious. The 5000 watt Vivor unit is a beast, weighing 12 kilograms compared to the 8 kilos of the 3000 watt one. It has more output ports, including a handy USB-C, and digital displays for both input and output voltages, which is a nice feature. The input voltage selection is also much cleaner on the Vivor, a simple 110 to 20 volt slider switch. The Joseon unit has 4 options, and my very first 3D print for this project was actually a small plug to permanently cover the dangerous 200 volt and 110 volt input settings. Both transformers are protected by a main circuit breaker and a secondary thermal overload button, but the Vivor's breaker felt much more substantial. Now here's where things got really interesting and completely flipped my expectations on their head. I assumed the smaller 3000 watt unit would be more efficient. I was wrong. I plugged them into my power meter and measured. Just sitting there, turned on, but with the printer off, the 3 kilowatt transformer wasted 8 watts, the 5 kilowatt one, only 6 watts. That difference adds up over time. With the printer on, but idle, the 3 kilowatt setup drew 32 to 36 watts. The 5 kilowatt one, consistently lower at 28 to 34 watts. And the peak startup draw for a PETG print where you don't even need chamber heating was the final proof. The 3 kilowatt unit pulled 1440 watts from the wall, while the more efficient 5 kilowatt unit only needed 1360 watts to deliver the exact same power to the printer. So the decision was easy. The 5000 watt Vivor is our permanent solution, handling the printer's absolute peak draw using less than 30% of its capacity. That's a massive safety margin. Now, how does this US spec printer on a transformer compare to a native EU unit? Igor was kind enough to run the same heat-up tests. The results are clear. You can see them side by side. We both start to heat the bed. Those are the bottom timers, and you'll see Igor's EU 220 volt unit on the right side reach 110 C first. That's when the bottom right timer stops at 202, followed by the US 110 volt unit taking twice as long, stopping at almost 4 minutes. Now we started chamber heating parallel with the bed heating. Those are the top timers, and again Igor's 220 volt unit gets to the target temp of 65 C first at 1422, and we have to wait 25% longer for my 110 volt chamber to heat up, taking almost 18 minutes. No surprises here. The native EU version is significantly faster. But here's a thought from the optimist in me, and perhaps a small consolation for our American viewers. Is faster always better? There are some interesting, if unintentional, advantages to a slower heat-up cycle. First, a gentle, more uniform heating process puts less mechanical stress on the big aluminum build plate, reducing the long-term risk of it warping. It also means less thermal shock for the heating element, its connectors and solder points, which could lead to a longer lifespan. And finally, think about heat soaking. With our European mains heaters, the bed reaches its target temperature incredibly quickly, and that's why we need to wait a few minutes for that heat to spread evenly before running a bed level scan. On this US unit, that heat up soaking is effectively happening during the slower warm-up. The process is more gradual, and might lead to a more stable foundation for that first layer. Now, before any US-based viewers think about importing an EU model to get these faster times, don't. Your standard 15 amp US household circuit simply cannot handle the much higher power draw. You would need a special high amperage outlet, like one for a clothes dryer, to even make it work. Besides, heat up is only one part of the preprint procedure. The printer is busy doing other things while we wait for the bed to reach printing temperature. So faster heat up doesn't directly translate into faster startup. With our power situation sorted and our printer running safely, it was finally time to see what it could do. Let's talk about the actual Bambu printing experience. After about a week, Igor messaged me, "So how do you like Bambu?" And I'm sure this is on the mind of many of you, seeing our long history with Sovol and other brands, now possibly getting sucked in by the dark side. But you know me, I get excited about every new gadget, so put my enthusiasm where it belongs. I'll do my best to stay objective. First Bambu Studio, their slicer. The best approach here, in my opinion, is Sovol's, embracing the open source Orca slicer. I've ditched the skin Orca versions from FL-Sun and Chiditech. For multicolor, I've had to use Anycubic slicer next and Creality print. Crealities is still annoying with its mirrored UI. Bambu Studio is another Orca-like fork of Prusa slicer, but with some key differences. Printer selection is different. The ability to sync nozzle and AMS contents is nice. As for feature set, I first missed some random features like mouse ear brims, then found them here, and these are so much better. But our favorite option, make overhangs printable, is still missing. That's a huge loss. Let me know in the comments below if it's there somewhere. The printer integration is best I've seen, though I did find a bug where filament settings didn't seem to stick. The workaround is to set them on the printer itself. Next, Bambu Handy, their phone app. Creality Cloud comes closest, while others mostly rely on a stock Obico experience. Bambu Handy is not bad, it's probably the best of them all. The live video feed from the printer is remarkably smooth, for example. But all this is just creature comfort. The biggest question is print reliability, quality, and speed. My first prints were in PLA. For a single color test, I printed said power converter cover, a 3D Banshee, and that self-printable scraper. I agree with Igor, it's freakishly silent printing PLA with the doors closed, and no problem with the automatic top venting door here. For multicolor, I printed the 4-color turtle to compare directly against our results from the K2 Plus and Anycubic Cobra 3. Can you tell the difference? It's on par with the Cobra 3, even the waist is almost the same. Then I moved to PTG. I concentrated on designing and printing a venting connector for the poop chute to help safely print toxic materials like ABS or ASA later. It's a work in progress, but my aim is to create negative pressure inside the printer so fumes don't escape. It turns out the door on the chute might seal too well, so I might need to find a different approach to suck air out of the printer. This is already basis for a separate video, so stay tuned. I'm open to ideas, please comment below, and while you're there, please like and subscribe if you haven't yet. If you have, big thank you. So this led me to printing ASA. The goal here was to advance our Sovol SV08 Max, making it capable of printing high-temp filaments in the future. For now, we need machines like our Chidi Q1 Pro and this new H2S to print the temperature-resistant ASA housing of the eye heaters we are planning to install in the SV08 Max. I was going to reprint the covers, the H2S being able to do multicolor. I loaded the 2 colors of the King Rune ASA from AliExpress. These printed well in the 50C chamber of our Chidi, given we added enough of glue and brims to the object. My first attempts on the H2S failed spectacularly. The nozzle just knocked pieces of the first layer around. I tried more glue, drying the filament, nothing helped. I actually gave up and ordered both a smooth PEI plate from Bambu Labs and a BTT cryo grip glacier from AliExpress to test later. Maybe we'll be more successful with those. Upgrades like these are made possible by the kind sponsorship of PCBWay. We even threw in a pair of nozzles, sizes 0.2mm and 0.6mm, the latter recommended for carbon fiber ASA. Big thanks to PCBWay for enabling these upgrades. Then, as I resumed printing PETG, I realized something. The glue stick I was using was making the build plate slippery, ruining its adhesion as well. I washed the plate thoroughly with hot water and soap, then wiped it with 99% isopropyl alcohol, and then I tried again. 60C chamber, 100C bed, and I even forgot to add brims. And it was a total success. My first multicolor ASA print on the stock textured PEI sheet. Finally, carbon fiber ASA. To complete the high temp upgrade of our SVO8 Max, we'll also need cooling for its toolhead electronics. I set out to print 3D Print Demon's modded toolhead cover out of the Erie 1 ASA-CF we recently found on AliExpress, a tough filament that should be able to withstand temperatures even slightly over 100 degrees, ideal for a toolhead cover. Surprisingly low price for a kilo, and a beautiful shade of blue that matches the aesthetics of the Max. Abrasive filaments like this need a bigger nozzle, which was a perfect excuse to test the quick swap nozzle system and the new smooth PEI plate from Bambu, sponsored by PCBWay. Now, nozzle changes can be terrifying. I recently messed up my SVO8 Max doing just that. On the FS on S1 Pro, it took 40 minutes and 19 screws to get to the nozzle. Here we were promised magic, and I was ready to see magic. I won't bore you with more setup, just watch. Make sure the nozzle is cold, pop off the cover, no screws necessary, pull off the silicone sock, flip open the hot end buckle, take out the magnetic hot end, insert the replacement, reverse the steps, and tell the printer you made the change. Done. Yes, we've seen magic. True, it's not really a nozzle change. We replaced the whole hot end. And an assembly like this costs 10 times as much as the 24-pack of MK8 nozzles I can get for my Max on AliExpress. At the end of the day, it's convenience versus open standards. And how did the print go? Minimal supports, minimal brims, no glue, perfect adhesion while printing, a bit too hard to remove from the smooth plate. I might need some of that slippery glue next time. Supports came off easily. Surface has these little gaps. The filament will likely need a bit more drying, but printing ASA feels as effortless as PLA here. A new perspective for sure. The H2S is not our fastest printer, far from it. I test printed the part out of PLA both on the H2S and our FS on S1 Pro. The quality is actually comparable on the two. The print times, 2.5 hours on the H2S and exactly half of that on the S1 Pro. But the ASA-CF version from the H2S looks just as good and is ready for assembly. We'll get into it in our next video about the SVO8 Max. I don't think I have to waste your time detailing our first impressions of the H2S. They are good, very good. Are we still going to use our other printers? Of course we will. Our SVO6 Plus is still our best for flexibles. Nothing comes close to the speed of our S1 Pro. Anything beyond 4 colors, our K2 Plus has the 2 material changes hooked up. Toxic fume extraction is best implemented for our GDQ1 Pro in our workshop, at least for the time being. I've put a 0.2 millimeter nozzle in our Sovol 0, and it's becoming our permanent printer for miniatures. And for big prints, the K2 Plus and the regular SVO8 can both print slightly larger, though of course nothing comes close to the SVO8 Max, which will soon be printing even high-temp filaments as well. Besides, the intelligent 120-degree eye dryer needed for true high-temp printing can only be connected to fully open clipper printers like our Sovols. So, who should get the Bambu Lab H2S? If you're looking for a reliable fire and forget machine that delivers top-tier quality with minimal fuss, and you value convenience over open source tinkering, this is a phenomenal choice for you. And we still can't believe we got it. To learn more about that eye dryer, watch our videos about it and other amazing collab with Igor in this playlist. And for direct comparison, our first impressions of the K2 Plus are in this one. Now on our H2S2, let's go print 3D. Thank you for watching another gerGo Print 3D video all the way to its end. Welcome to the dark side.